Okay, in this video lecture, I'm going to cover 14.2 Part 1, which starts to look at acid-base theories. And what acid-base theories is that, you know what? There's more than one way to describe an acid or a base. And a lot of the definitions of acids and bases had to be revised, and so they developed the acid-base theories. So I'm going to focus on something called Bronsted Lowry acids and bases, okay, which is an expansion of Arrhenius acids and bases. So remember that with Arrhenius acids and bases, the definition that defines an Arrhenius acid is the chemical compound that increases the concentration of hydrogen ions in an aqueous solution. So you have hydrochloric acid and you put it in water, and those ions will split, like pull apart from each other, and now I have H plus floating around and Cl minus increase in the number of those hydrogen ions that are present. Or if I'm looking at an Arrhenius base, a substance that increases the concentration of hydroxide, OH negative, in an aqueous solution. Okay, so that was Arrhenius acids and bases. They were limited because it had to be in a solution, okay, aqueous solution. So this new definition with Bronsted-Lowry expands on that, where H plus is a proton, and so all acids are defined as Arrhenius, are also Bronsted-Lowry acids, and it includes ions, not just protons. Ions can also donate protons, and if they do that, they are considered Bronsted-Lowry acids. So if you take a look at this example here, I have Bronsted-Lowry acids. It donates a proton to another substance. That's it. So I have hydrochloric acid in water, and the hydrogen gets donated to water and becomes a hydronium ion and a chloride ion. So HCl would be considered my acid. And the thing that accepts the proton, which is going to be the next vocab term, is the base. So this is my acid, and this would be my base. So Bronsted-Lowry bases accept a proton from another substance. So here I have NH3 and water, and when I combine them together, you notice that on the product side, NH3 is now NH4. Well, where did I get that hydrogen? I got it from water, and I'm left with an OH negative, or hydroxide ion. So NH4, okay, accepted that proton. So when I ask, hey, which one of these is the acids and which one's the base, and you look at the product side, well, NH3 gained the proton. So this is my base. This would be my acid. So part of your assignment will be looking at a chemical equation and looking for the transfer of a proton. And the thing that does donate the proton, so here I have HCl, okay, and now it's just Cl, well, it lost that proton, so it donated. This is my acid, this is my base. That's it. So we call these Bronsted-Lowry acid-base reactions, where protons are transferred from one reactant, which is the acid, to the other, and that is the base. So here I have my acid with that proton, and it's going to donate that proton to the base. And the product side, I'm left with, well, they call it a conjugate base, and this is my conjugate acid. These are terms that we will discuss in a different lecture. But for your homework, you would say, oh, well, this proton is now part of the B, okay, because I looked at the product side. So this is my acid, and this is my base. So let's do a couple examples together. Hydrochloric acid plus NH3 produces chloride and ammonium, NH4. So here I have this HCl, and I look on the product side, and I notice a Cl is by itself. Well, where did that H go? Well, if I look, it got transferred to the NH3. So now NH3 is NH4. So the thing that donates a proton is my Bronsted-Lowry acid. So I would say, well, is it not going to show? Well, it's supposed to have a red circle. There it is, up here. So that is my Bronsted-Lowry acid, and the thing that accepted it is my Bronsted-Lowry base. All right, take a look at the next one, H2O plus H2SO4. All right, let's take a look at what happened. All right, H2SO4, I look over here, it's HSO4. Oh no. So this H got denoted, or why do I keep saying denoted? Donated, oh my gosh, to the water. And I'm almost positive I have the colors mixed up here. Gosh darn it, now that I think about it. Let's just find out. I'm pretty sure I put the wrong colors. So this H2SO4 donated a proton to H2O. So now H2O becomes HO3. So this is my acid. Oh, I did it. Yes. And this is my base, my Bronsted Lowry base. As soon as I find the right place to click. All right, take a look at the last one here. Sorry, I couldn't fit it on one line. CH3OH plus HNO3 produces NO3 plus CH3OH2. All right, so here you can see that my HNO3 becomes just NO3. It lost the proton, okay? So the thing that loses the proton, well, it actually donated it. So this is my acid, and this is my base, because this accepted it. And you can see that this one is not balanced. Oh no, well, yes it is. Never mind. Silly me. So there we go. All right, now some acids, the ones that denote the proton, can be classified as either monoprotic, diprotic, or triprotic. And that just means how many protons can it donate. So a monoprotic acid is an acid that can donate only one proton per molecule. And this would be your simple hydrochloric acid. That one H gets denoted to water to turn it into hydronium, and then chlorine is just floating around. So here are some other examples of monoprotic acids. Nitric acid just has the one proton there. Acetic acid, I believe it is the last H on here. Benzoic, the last H here. Hydroic acid. And then we have our hydrofluoric acid, but again, just one H. Now the cool thing is you can see with like a sensor, a pH sensor, when that proton gets donated. So over here I have pH. I have something that's extremely acidic. Low pH means acidic. And when it starts to donate that proton, okay, we call that the equivalence point, and it usually you see plateaus and then it increases, and this is where that proton is being donated. Polyprotic means you are either diprotic or triprotic. So an acid that can donate one or more proton per molecule. More than one. Wow, not one or more. More than one proton. So diprotic means that it can donate 2 protons per molecule. So here I have H2SO4. And when I take a look at this chemical equation, H2SO4 just becomes HSO4. And then in a second reaction, it can lose that H and form another hydronium. Okay, so you see 2 stages of ionization with this one. So some examples: absorbic H2, carbonic H2, oxalic, phosphoric, sulfurous, sulfuric. So anything that really starts off with an H2 is diprotic. Triprotic means that it donates 3. Okay, so this H3PO4 becomes H2PO4, but then that molecule can interact with a different water molecule, and now H2PO4 becomes HPO4, but we still have a proton that can be given, and it can interact with a different water molecule and form hydronium, okay, and just plain PO4. And again, you can see the changes in that. As it loses protons, it becomes more basic. Okay, so now your homework assignment, okay, it looks something like this. I'm not going to do all of it, but this first part is you're either labeling as mono, di, or tri. Basically, look at how many protons, okay, aka hydrogens it has. And if it's 1, it's mono. If it's 2, it's di. If it's triprotic, it's 3 H's. Second part is using the Arrhenius definition, classify the examples as either acids or bases. So Arrhenius, remember, means that it can donate a proton. So HBr, can it donate a proton? Yep, you bet, that's an acid. MgOH2. Now, notice that this OH is grouped together. Is OH acidic or basic? I hope you're recognizing that OH means basic. This is a base. Okay, it will accept a proton and become hydronium. What's another one I want to... Okay, take a look at this one. Does it have an H? No. Does it have an OH? No. So we're not going to label it as acid or base. We are going to label it as a salt. So that's how you do the second part. Third part is looking at Bronsted Lowry acids and bases. So remember that the acid is a proton donor and the base is the proton acceptor. And how I want you to show this is, let's just do the first one together. I have two water molecules. Yes, water can behave as either acidic or basic, depending on, what it does with its protons, its hydrogens. So I have H2O plus H2O, and you see that it goes back and forth to produce hydronium and hydroxide. So this one, okay, H2O becomes H3O. So that means that this one donated the proton. So if it donates, okay, this is my acid. I want you to label it as A, or if you want to go BLA, I don't care. And the thing that accepts it is your base. And so we're just focusing on the reactant side. We'll talk about conjugate acids and bases in a different lecture, so then you'll be able to label everything. But right now, let's just focus on the reactant side. So that is the homework assignment for today.